Thank you all for joining our webinar today. We're going to talk about automation for production quality and configuring workflows and pass-fail criteria. Just a couple of things before we get started. First, I'm Abby Lindberg. I lead GelSight's applications engineering team. Feel free to use the Q&A throughout the session. We have Frank Chang from my team answering questions live, and then we'll have time for some Q&A at the end. And we're also recording this webinar, so we'll get that posted to YouTube once we're wrapped up. With us today, we have Dennis Lang, so I'll pass it over to him to introduce himself and get the webinar started.
Yeah, thanks, Abby. I'm Dennis Lang. I'm the Chief Business Officer here at GelSight, and we're really excited to talk to everybody about this topic today. Automation for production quality. This is something that GelSight has built into our platform, really based on feedback from users. So really, what we have done over the course of years and successive product releases here at GelSight is create a software package that takes the lab grade measurements and make them usable, repeatable, and actionable right on the manufacturing line. So we have a hardware solution that was already mobile, but we needed to add more and more software features. And this is the beauty of having software-enabled hardware where you can do these kinds of things. So as a part of this, we put a lot of emphasis on simplifying and hardening the workflows. Cloning features lets you replicate proven measurement setups across multiple lines or sites without rebuilding anything. This is a feature that in numerous industries I've used in past lives, and having it here at GelSight, we've had great feedback from customers. Renaming and organizing analysis routines reduces operator error and allows you to name GelSight routines aligned with those of your organization. So GelSight might call something offset, but in your team, you might think of it as a profile, and you could rename it as that, in addition to the customizations you can put into the routine. Along with that, the pass-fail criteria and configuration solution is at the core of this. It lets you codify your criteria so the system makes the decision the same way every time. So it's not objective, it's not qualitative, it's quantitative, and it's captured. The goal is simple. Make the micron scale decisions at the point of use. That's always been kind of the ethos of GelSight since we made our solution mobile. Instead of sending your part to a metrology lab or waiting in line at the metrology lab, the operator gets an immediate answer using GelSight right there at the point of need. You have lab accuracy, but you don't have to leave the production or the inspection workstation you might be at in the field. This keeps quality decisions close to the process. It eliminates rework loops, and it also creates an intelligence on the part of the operator because they're getting that immediate feedback on choices they're making as part of their production flows and the consequences that has on the product they are manufacturing. Well, a lot of teams really do start with GelSight in the lab, and even today, this is still true, even though the solution is mobile. But getting out of the lab, we know there are different needs for those user personas. And an operator mode is something is a controlled, simplified interface that's ready for your production uses. You lock down the parameters, remove the guesswork, and any trained operator can run the workflow with confidence. It's how you bridge from the engineering and metrology lab to the production or the floor. We have many examples at GelSight around these features, but maybe telling the story of a couple could get you thinking about how you could use GelSight in your workflows. One example would come from fuselage assembly. Our customer had operators that were struggling with subtle surface defects, barely visible, easy to misjudge, and they also had workforce turnover that they had to deal with. So how do you quickly get an operator up to speed and making inspections on the production line? With operator mode and automated defect detection, we upskilled those operators without changing the team or having long training cycles. The training cycle with GelSight's pretty darn fast and really does allow that turnover or training multiple shifts to be a very simple thing for us to do. The system guides the user, it captures a consistent measurement, and it makes the call with the data that has been set up in the system. It compresses the years of experience within the organization, perhaps decades or more, into the saved and codified routine that you've customized in minutes. And finally, for our more advanced users, we have an API that we launched last year. And this is what really makes automation scalable. So instead of measurements living inside a report, living on the local PC or the Surface tablet, if you have that sort of system with GelSight, customers now can push the results directly into manufacturing and quality systems direct from the GelSight software package. Whether it's go, no go, or the full surface map, all of these solutions are available through our API. It flows directly from the GelSight system into the systems that run your factory. That's really where automation stops being a tool and becomes part of the manufacturing backbone of your business. So this allows you to start making decisions about the dispensation of a component right there on the line very quickly, and it's documented with digital record keeping. With that, Abby can really demonstrate some of the customizations that we have and what the API looks like here, and get you thinking about and maybe asking some questions about how you could integrate it into your workflows.
Awesome. Thanks, Dennis. So yeah, exactly. So we'll walk through how we can do all of that in our GelSight software next. Stop sharing the slide here, and we'll switch over to another view. But first, we'll start with a little bit about how GelSight works. And today, we're going to be using the modular system. Right now, I've got the straight lens attachment, and we'll also use our 90-degree attachment later, which we'll just switch between the lenses for the webinar. And we've got our camera system in here, and we've got our lens and illumination in here, and then we have the gel on the end of it. And when I'm clicking that button, I'm taking a series of images and using those to reconstruct the 3D data. And working in conjunction with the gel is how we're going to get to any of these surfaces, regardless of their optical properties. And the last webinar that we did where we talked about calibration, we had Kibo Johnson join us, our co-founder and chief science officer, and he did a really good job explaining kind of the fundamentals of photometric stereo and how GelSight uses that. So I definitely recommend checking that out if you have more questions about how GelSight works. With that, I'm going to share my screen and I'll also share my desktop. And since I'll be sharing both of those, if you need to switch between which one is your main view, just go ahead and click on one if you want to see the video larger, or click on the screen if you want to see the screen larger. So let me jump over and share that. Now we should see my desk. And then let's go ahead and share the GelSight mobile software. Let me grab that. Here we go. And we'll go live. All right, so the first thing that I'll do, just to give a little demonstration of what we're doing, I'm going to press my fingertip into the top of the gel here to give you an idea of the resolution. You can see my fingerprint there. And the first sample that I have on the desk here is going to be a blade. And we'll take some scans of different defects on this, and we'll talk about how we can configure the automation associated with this analysis. So the first thing I'll do, we've got a defect here near the root of this blade, and we'll take a look at that with the Modulus straight lens. And this is something that we didn't previously have access to with just our Series 2 system. This used to be a replica workflow for many applications. Our 3D data is generating now, and then we'll be able to open that up and take a look at our analysis. All right, so here is our scan, and let's take a look at the 3D. Here's our reconstruction of that surface and that defect. And we'll jump back over, and maybe we want to measure the depth of this. Definitely want to measure the depth of this. So I'll select defect detection for this analysis. And we can define a region of interest, or we can run it on the full field of view. I just drew a box for this one, and we'll click Analyze. And there are the characteristics of the deepest defect in the field of view. So we can see the profile through the deepest point, and then we can come and turn all of this into a PDF report. And we can customize the view. Maybe we want to look at the 3D like this, and zoom in on it, and add some custom notes or whatever information you want to include in your report. So this would be the basic way of measuring a defect with GelSight. But now how can we add in some of the automation that Dennis talked about in the beginning of this? Adding different pass-fail criteria or cloning functions to make sense for your application. So for that, I'll actually jump back to analyze, and we'll talk a little bit about this defect here. So we found for a lot of applications, even on the same part, you might have different tolerances, whether maybe there's a stricter tolerance for defect closer to the root of this blade and a looser one on this part of it. Or this could be a different part completely. And what we might want to do is name our functions so that our operators know which one to use for which type of part or which part of the blade, depending on different pass-fail criteria. So we're going to get into customizing these functions now. The first thing that I'll do is I'll actually come into our advanced settings of defect detection, and I'll click Set Defaults. And what that's going to do is that's going to add this box to my function. Now, every time I click defect detection, it's going to have that same search region. I mentioned before, you could run this on the full field of view or define your search region here. And the next thing that we're going to do is come into Configure and Analysis. And this is where all of our customization is going to happen. We can see our defect detection function on this list. And I think the first thing that we'll do is we'll clone it. Maybe we'll name we'll call two different functions. We'll call this defect region A and defect region B. And we're going to look in this region have one set of tolerances, whereas the other region will have another set of tolerances. So that's why we're kind of cloning it between two functions. So now we can just pick whatever region we're going to be scanning a defect in, and it'll use those pass-fail criteria, the ones associated with that region. We found actually a lot of our customers use this just to rename functions, as Dennis mentioned in the introduction here. You know, we have a pit detection function that is used pretty often for part marking. What you might want to do is just rename pit detection part marking so that now your operators don't have to say, oh, what was the function that I used for part marking? Oh, it was pit detection. Well, now it's just labeled part marking. Same with, we use the offset function for defects on edges. Maybe we just want to call it edge defect, and then you know which one to click on. So all of that's customizable just on a base level here with this new variant button. So I'm going to come in here and we'll call this defect region. We'll do a capital R, region A, and we'll click OK. And we'll add some pass-fail criteria. So on the bottom here, we can see all of our outputs of our function, and we have this checkbox for pass-fail. And maybe the allowance for defects in region A near the root is going to be 25 micron. And now we'll come back to defect detection. We'll add another variant, and we'll call this one defect region B. And we'll click OK. And we'll configure a second set of pass-fail criteria for that other area. We already set the defaults with the search region, but this could be an input that's changed between functions too. Maybe you want a different region of interest defined between these. But for now, we're just going to set up different pass-fail criteria. So we'll say this region of the blade has 100 micron tolerance. And then we can go back to capture, and we'll take another scan and run that analysis. So I'll come here and we'll scan that defect again near the root of this blade. Go a little that way. And once we get that data, we'll go run that analysis function. You can see it's generating the 3D now. And we'll pick our defect region A function here. And we'll click Analyze. And now we get that big red fail symbol. All our profiles red, everything's red. It says depth value of 40 micron exceeds upper limit of 25 micron. So really big indicator of failure. This is outside of our tolerances. So for this, we still took the scan, we went to defect detection, we added it, and we saw our pass-fail criteria, and we saw our result. But we can also automate that even further from the capture page. So if I come back to capture, and I know I'm going to be scanning a specific region, I can run that function here. So I'll say defect region A. I know I'm going to take a scan in that region right now. So I'll go ahead and we'll scan that defect again. And next, we'll scan a defect on region B. So we'll actually switch the routine. I'm going to say I'm looking for a defect in region B now. And I'll scan a defect in this area here. Let's see. Something, go a little further down right there. And we'll take that scan. And we can see actually the previous scan already finished processing, and we got this red box. That's our indication that that scan failed. We're outside of our pass-fail criteria. And we can see this one just said it finished analyzing defect region B, green box. So we are within our tolerance here. We can open up those scans and see what those results were. We can find that defect here. And we'll jump back and we can look at that first scan as well. So we can see that failed scan. So the next thing that we can also do is this operator mode interface. So you can see right now we still have access to all of the analysis functions and all the customization. But if you're going to be using GelSight for really strictly one task, like Dennis described, the defects on fuselage, they are always using the same configuration. They're always using the same pass-fail criteria. We can actually lock out the GelSight software with a simplified interface. So for that, I'll actually switch to another sample that we'll take a look at. And I'll switch to our 90-degree lens because we're going to look at a defect inside of a bore here. So I'll just disconnect our straight lens and slide in our 90. And we'll lock that in. It's ready to use now. And we'll go to our operator mode. So on the top bar here, we see our operator mode selection, and this is where we configure our operator mode. We can password protect this, so you can't. So you need the password to exit operator mode. Make sure I know what the password is. There you go, it's password. And then we can also configure where the scans are being saved. So all of our data is going to be saved in this webinar operator folder. And we can also configure access. So do we want our operators to be able to calibrate, or do we just want them to be able to switch to pre-calibrated gels? So that's what we're enabling here. And we're also going to specify the routine that we're going to run. So I'm going to check this box and we're going to run defect detection. And this is that first one that I cloned. And this is before I entered pass-fail criteria, but you can add that as well. And I'm going to scan a defect inside of this bore. So for that, let's click start and we'll look at what's in operator mode. We can see that box. That's where we're going to put our defect. And I'm just going to take a scan here with this defect inside the field of view. We can see it's following that same process, aligning the images, generating the 3D, analyzing defect detection, and here are our measurement results. So we've got all of that popped up here. We can see the depth, and the only option we have is to click redo scan or click next scan. So I can click next scan and we could take another one or redo, but now that I've clicked next scan, I can't go back and delete that. So it also prevents any sort of, it helps with traceability. You're going to have all of that data that you took. And I'll actually exit this interface and we can talk about the API, which I've had running in the background while we've been doing this demonstration. So I'm going to switch my screen share and we'll actually jump over to our API demo. Let's see, we've got this one here. So this whole time I've actually been connected to our system with our API demo sample code application. We can see I'm connected to a device, and this is kind of we've had our customers use this as a starting point to develop their own applications. So what we can do here is we can actually subscribe to the live images. So now we can add our live image to your own custom software application. We can request analysis, which is the same as taking a scan. And we can even, here, I'll clear the messages so we can see it. We can subscribe to the gel state as well. And this will even tell us when we're making contact with something or not. So this is pretty exciting for us. But you can see once I touch it, even in just a small location, we start making contact, it'll flag it. So And as we do analysis, all of that analysis results will pop up here too. So whether you're using this for kind of robotic integration, or whether you're using this just to port your results over to an ERP system or something else, we have the ability to do both of those, and the sample code provided can help you with that integration. So with that, maybe Dennis, could you kind of summarize the value that GelSight brings for these types of applications?
Sure, Abby. And we hope this webinar is kind of helpful. The reason we came up with a concept for what we've been presenting here today is the number of customers we go to that say, "Oh, wow, you have these features. I had no idea. I've been using GelSight for years sometimes." So, we really wanted to make sure that you users of our system out there knew these features existed. And really, it's been about delivering lab grade surface data at production speed, digital traceability, and it's built into every step of your production flows. Our software is built for the floor. Once you lock in a routine, it runs the same way every time across operators, shifts, even sites. With the digital traceability, you can go back to your data after the fact, whether it's a results table, it's an output to the API, or you just look on the hard drive of the local machine and you're able to look at reports later for what's been going on in a particular site. We have customers that take old data, many years old data, and bring it back into GelSight and do analysis on it today as part of their trend monitoring or their simulation of new designs where they now have data from GelSight that they didn't have before. When teams are ready to scale, the API really opens the door. That was really the next step of the journey for our platform. So you can push the results automatically into your production or quality systems. As we discussed before, there's no manual transfers, there's no disconnected data. The data pushes automatically. You don't have to remember to do it. The same API also enables deeper automations. GelSight has multiple partners in the space who we've partnered with as part of their solutions. But in addition to that, we have customers who integrate us into their workflows. They 3D print fixtures. They use different ways of integrating the system all the way to lights out manufacturing in one cases. So with these types of integrations, we get a lot of feedback, and our API has changed over our successive software generations. But what we typically hear is how well documented and easy our API is to use. So we would love for more people to use it and give us the feedback, and we will keep improving it. So with that, speed, traceability, production control, and open integration in your platform, that's really what GelSight has been about for many years now.
Thanks, Dennis. And I think with that, we should have plenty of time for questions at the end here. So go ahead and use that Q&A section at the top. We'll answer some in the chat, and we'll also answer some live right now. And just a reminder, we will be posting this recording to YouTube as well. So it looks like we do have one question here. I think Dennis and I both might want to answer this one. It says, how could the quality check of a whole part, the whole surface, look? May it be possible to apply an automated measurement routine with many measurements in a row, for example, with a robot? Dennis, do you want to go ahead?
Yeah, there's a couple of different ways you can do this. It's public. We have a partnership with Hexagon. Actually, I see at least one person from Hexagon here today. And we connect to their arm. And with the arm and GelSight solution, you are able to move around the surface and track your measurements on the 3D model of the system. So feel free to reach out about that, and we can definitely get you up to speed on what that solution looks like. In addition to that, we are also deployed on robotics. So whether it's a universal robot or another kind of robot, people have integrated GelSight systems onto that. You can actually find some of those kinds of pictures on YouTube. We had at IMTS, we had a robot running. Many of our customers, unfortunately, don't let us show. But we've had different kinds of aerospace applications where people are automating that. We've had circuit board automations where they want to do inspections of locations all around the board per a test plan. So hopefully that answers your question.
Yeah, and I can add something else to that too. We also find a lot of people use our system in areas of known defects. They might not see a defect in it currently, but they know that that's a common spot for defects to occur. So it might not be scanning the entire part necessarily, but it's more than just where they find a defect. They are also spot checking, common stress points as well. All right, looks like we have another question about naming conventions. So can I change the names of the scans to match my application? And I'll share my screen again in the software just to show you what that looks like. We'll jump over here. And we'll share that. All right, so in the bottom left corner of the capture page, we have this field for the name of the scan. We can actually configure the name of the folder that the scans live in here in the top corner. And then we can also configure the name of the scans themselves. So as we take them, you'll see throughout this demo, we've taken several scans here, and it just depends on the number each time we take one of those scans. This is also, I believe, a customizable tag through the API as well. So if you did have some automation, you could change these based on whatever your internal system is telling you as well, or even use a kind of barcode reader in keyboard mode to input a name there as well. All right, we've got another question here. It says, are we able to share a dummy generated report? And yeah, we can reach out after this and send over a PDF report. This is definitely one of our the key output for a lot of our customers is going to be the PDF report. So we're happy to share that. We'll follow up after this. All right, and we've also got what is the API language? I believe we're in C++ on GitHub right now for this version.
Yeah, I see about a follow-up to scanning areas of the park. Yes, roughness would be one of the things we could do of many different. So we do both surface and profile roughness. Our profile roughness tool is pretty cool. It allows you to set up for one line definition. It allows you to do just roughness over one line or average it over many lines up to 21. So yeah, and then of course surface is just the surface area you select or the whole area. And so Abby's showing the profile roughness now.
Just a quick little look at that, yeah. All right, so we'll give just one other minute for questions here. So feel free to get them in for the last minute we've got. All right, so I think we'll wrap up here. So thank you all for joining, and we'll post this on YouTube, and we'll follow up with any other questions that come up after we end the session. So thank you all.
Thanks, everybody.